Good afternoon. My name is Dr. Okorie. I am at University of Exeter, and I'm a research fellow in circular technology, and I'm working on the topic on digitalization, circular lessons from existing academic research. So I work at EGCI, which is the Exeter Center for Circular Economy. I finished my PhD at Cranfield University, and before I finished, I started a research fellow role there, looking at an EPSRC project that was combining circular economy and Industry 4.0. It's a 3-year project, and this is the last year of the project, and it's been going on quite nicely. I will be drawing out from lessons from that project and also a few from existing academic research. So I'm just gonna go to the next screen. So you can still see my screen, right? I believe. Okay. So I will be talking about the circular economy. I'm sure we've heard that a number of times today. A number of trends as well, some case studies, and also what I would call conclusions and next steps. So existing economy, I would say, manufacturing economy is actually based on the take, make, and waste, which is a linear economy. And studies have shown that most of the world economy is still quite linear and not circular. So this work we're doing is trying to make that process from linear to circular a bit much faster. So a closed loop thinking for firms in the past often meant that being green or eco-efficient is not a core activity. So most firms obviously look at things like profitability, but supply chain management and linkage with sustainability owes much to closed loop and remanufacturing. Remanufacturing is one of the circular strategies as well, which I've used in my current work. And product recycling or remanufacturing was really seen as value creating system. And the circular economy essentially has two key things. It needs to embed value in the system, and also it's a rich feedback system. And Carter and Rogers were the first to demonstrate a relationship between environmental, social, economic in supply chain management, which is actually where we can place plastics in. And this is in the triple bottom line. So this is the circular economy. I will not stay too long on this slide because I'm sure we all know it. So it's a rich feedback system, and it's an alternative to our linear economy, which is take, make, dispose. This is take, make, and reuse, recycle, etc. And we tend to keep resources in the system as long as possible while we are trying to extract. We want to extract maximum value from it. And the next slide you see is the digital trends. So it's very undeniable that we've had a number of digital trends, digital technologies in the past few years, over the last decade. This diagram is from Made Smarter Review of 2017. And we can see that just beyond profitability, firms can have benefits such as increased productivity, a reduction in machine downtime. And by 2020, by the current year we are in, this forecast is expected to explode around 50 billion. Now, this research was conducted in 2017, and obviously we had the pandemic of last year, so that might distort the projections. Okay, so quickly, these are some of the intelligent assets. Intelligent asset basically means that you have an existing product which is embedded, which some intelligent device is embedded into it. So for instance, an RFID or sensor, and it can then ensure things like monitoring performance has increased. It can extend the use life cycle and also redefine maintenance as well. Now, very quickly, just looking at CE trends in the last 10 years or the last 10 years and above, we can see that from publications on Scopus, it has increased. And this is looking at global trends. I will be very quick from here. And when you go down to Africa, it's actually not so much in comparison to what we see around the world. So I just did a scopes, and I just kept the I restricted the word circular economy and Africa as my search terms, and we can see that we are having 62 publications, and most of them coming from South Africa and the United Kingdom. I think obviously this is driven by the number of African academics who are in the UK and Australia and Germany as well. So, but we obviously want to see this coming from outside from the continent of Africa, and we can see the trends as well. So we can see that most of the publications have gone into articles, and they are from very diverse fields, majorly environmental, social sciences, and also engineering. And within digitization, that same uptake is actually seen. And it's in the past 10, 15 years, the uptake has increased, and it still will increase more because of, there's a lot of opportunities in integrating CE and digitization, and also for plastics. So what does it mean for plastics? Now, the emerging research question here is that we know that CE is emerging, but it has shown a lot of promise in tackling sustainability issues while retaining value throughout your product life cycle. And plastics remain a key source of pollution, like we know, and waste in Africa. Only 14% of plastics are collected for recycling, and 95% of the value of plastic packaging material is lost to the economy. So we're asking the question, how can this integral area of CE and digitization help enable this transition to a CPE in Africa? So I'll look at a number of case studies. So we look at the case study. We look at a case study which we took from where I work with John Lewis. So looking at a phone, for instance. So within a phone, we want to map that for showing a material cloth to be recycled. We need to map the key stakeholders, so we know that the product needs to be there. Then the big M, which is the manufacturer, John Lewis themselves, and also the social media communication, because you want to use the mobile phone device. And this is the estimate: about 140 million worth of clothing goes into landfill each year. So in this research, what we looked at is how can we make the consumer, return your old stock of clothes, so that then the manufacturer goes ahead to either recycle or remanufacture the material, and using an app device on the phone and making it as simple as possible. We can see that this was actually quite efficient for John Lewis. So the most important element while we saw this was working within our small scale of research was customer loyalty to the app. That use the app, the more likely the users will shop with John Lewis, and the more likely the users will go ahead to identify their product for. And obviously we also made some suggestions to John Lewis. So now, in looking at circular economy and in 1.0, what we came up with was a mapping tool, I would say, of circular strategies and data flows. So we all use this in our work with we work with a few companies, PSS who are into remanufacturing. I also go into that, and we saw here that if you can adequately map the circular strategy you can collect from literature, and the data flows which you can collect from either secondary data from key stakeholders, you can easily, I would say fairly easily, go ahead to help the remanufacturer, the recycler, to actually gain as maximum as possible value from that product. And I'll show you quickly how this works. But we'll look at Shoelab. Shoelab is a company in Brixton, a small firm, which we looked at their existing business model, and we wanted to see how we can actually make improve their business model to become more circular. Again, this is a firm that takes materials, uses it, and dumps it. So it, we know that consumers, for instance, they would expect the firms to be built to, consumers are increasingly knowledgeable about some environmental issues, and now we've seen that they expect the retail environment to be built out of local materials to reflect local taste and customs. So we researched here, and we then built a Shula business model for this firm, and this is what it involved. So we can see that we made it quite circular. So from the research product development, where the shoe can be recycled and then repaired, and at the second point of development, the repair is actually linked to a particular design which has been requested by a customer. So that circular loop continues, and the benefits of this business model was elimination of unnecessary parts. It was easy to assemble, disassemble, and also the consumer got involved with the manufacturing process. Again, please bear with me, I'll soon be done. So these are some of the questions we were asking in our work, which was looking at data-driven intelligence for a circular economy. And we worked the numbers. We worked it with River Simple. River Simple, a car manufacturer, what they do is that they make hydrogen fuel cell cars, and we want to see how we can actually remanufacture some part of the cars, particularly energy storage system, which has sensors in them already. It's the world's only independent hydrogen car company. And we went through the same method where we had to then draw up this mapping tool, and then obviously then went ahead to identify the points where River Simple will extract much value. So their business model looks around what is called PSS, or products as a service, where you share an existing product without actually buying it. So essentially, you pay for the service, and we found that the customers were more curious, and also for the client for identify user patterns. We have been employing a lot of simulation modeling in work. In terms of this, system dynamics, agent-based modeling, and descriptive event simulation. Agent-based modeling basically combines advantages from descriptive simulation. System dynamics is more theoretical, and it's based on a lot of on assumptions that you extract from the and DES is quite quantitative. So we employ this in a remanufacturing setup, and also we came up with a tool or a model to understand how we can actually this is a remanufacturer from the life of their product. Called CPQ, or certainty in product quality, and this was after we took some variables from the manufacturing. I was the one that was there, did some observation on the shop floor, and also then did some modeling on agent-based simulation. And in the end, we found out that with a high CPQ, the time spent in assembly and disassembly, clean, and inspection, these are the key aspects of manufacturing for it. And a low CPQ, this was the time spent as well. So most manufacturers will really want to stay within the high CPQ value. So just to conclude, I apologize, this was a bit fast. So in applying what we've learned in our Circular 4.0 research to circular plastics economy in Africa, there is the opportunity to implement digital technologies in enabling a faster transition to a circular plastic economy. Now, for Africa, because of our diversity with there, so I'm from Africa, it means that we would suggest a wider systems perspective. And taking a wider system perspective means including the complexity of regional, environmental, and ecosystem analysis levels. And these are some soft systems. I would normally advise for any academic researcher to try and employ as much as possible simulation modeling, because with that you can be able to map out small regions and work with small regions for whatever research you want to do. And mixed methods as well should be advised. And also these are the theoretical implications. So what does digitalization mean for the circular plastic economy? So it enables a feedback-rich system, and the opportunity to connect users to the materials, product flows, and their real value. So you can actually begin to develop new circular business models for that plastic, and that can then capture the locality as well of the area, and obviously open innovation. And like I did mention, the systemic approach. So finally, we have a center. It's the National Hub for Circular Economy Hub. We are one of we host the National Center. And for the CE community, I think most of the learnings from the CE community can be applied to a potential CPE community. And these are what I would think from my work so far. So I've been working on CE for the past, I think 6 years now. So these are what I think the requirements for a successful CPE community should be. Data modeling and metrics, there should be people within that area, knowledge and evidence. So we would prefer obviously real knowledge from within areas. And there should be communication and collaboration, and also initiation to implementation. And these are the partners which we work with. And thank you for listening. Apologies, I went slightly over time.